So now we're going to bring it all together. We're going to study how we can do successive, series, and parallel combinations to simplify a circuit to the point where we can really do a useful calculation. Looking here at the circuit for part A, you can see that we have a voltage source connected to 1, 2, 3, 4, 5 resistors. And if you said to me, what is the current, without doing the analysis that we're about to do, I don't have the slightest idea what that current is. It's going to be in the ballpark of 1 to 5 amps, but I don't really know. So what we're going to do is we're going to do successive combinations to simplify this circuit and find out precisely what the current is going to be. The first thing I'm going to observe is that we have two resistors here that are in series with one another, and therefore the equivalent resistance is going to be the sum, which is 7 ohms. We also have two resistors here that are in parallel with one another. And because those are two identical resistors, the equivalent resistance will be 1/2, and so therefore it's going to be 2.5 ohms. So I can now redraw the circuit. I'll redraw it over here to the right, and I'm going to have a 10-volt source. And it's going to come up here. This 2 ohm resistor was left unchanged. And by the way, the current that's flowing here was also left unchanged. So I have a 2 ohm resistor. These 5 ohm resistors were connected between the right side of the 2 ohm resistor, so right there, down to the bottom terminal. So I'm going to have 2.5 ohm resistors here. And then I have the 7 ohm resistors connected from that same terminal down to the bottom terminal. And so I have a 7 ohm resistor here. So I've reduced the circuit down from 5 resistors down to 3. And furthermore, I can now see that these two resistors are newly in parallel. So I can combine those two in parallel. I'm going to go ahead and calculate what would the equivalent resistance be. So our equivalent will be 7 times 2.5 divided by 7 plus 2.5. And that works out to be 3.842. 3.842 ohms. So I'm going to redraw the circuit again. And so here you can see that I'm going to have the circuit, the 2 ohm resistor still remains unchanged. That'll be the last thing that gets absorbed. So here we have, oh, sorry, this wasn't 3.842. I should have known that that couldn't be possible because it must be less than the lowest of all of the original resistors. It was 1.842. 1.842 ohms. And so 1.842 goes right here. We still have 2 ohms here. We still have 10 volts here. We still have the current I flowing right there. And now I can draw the final version of the circuit, and that's where I do combine those two resistors in series, the 2 ohms and the 1.842. That's where I get the 3.842 ohms. So I have 10 volts, and this is the current I. And now I've reduced the circuit down to the point where it's just an application of Ohm's law. I'm looking for the current I. This is going to be V divided by R. This is going to be 10 volts divided by 3.842 ohms. And that works out to be 2.60 amps. So we actually reduced the circuit in several steps. I kind of actually combined a couple of steps by doing the 7 ohms in series and the 2.5 ohms in parallel. Could have broken that into 2 separate steps, but I think that it was fine the way we did it. And then we reduced it down to a circuit that had 3 resistors, then a circuit that had 2 resistors, then a circuit that had 1 resistor. And at that point, we had enough information to calculate the current. Here we have a current source, and we'd like to find the voltage. Looking at this one, I can see that there's going to be several steps because the only thing I can really combine right now is those 2 resistors. So I'm going to have a 10 ohm resistor right here. I can redraw this circuit. So this is going to be the current source is 2 amps. I have a 5 ohm resistor here and a 10 ohm resistor there. There's 5 ohms. There's 10 ohms. Here's my voltage, plus to minus. I have a 5 ohm resistor and a 10 ohm resistor, which nothing has happened to either of those yet. And then I'm going to bring in this extra resistor that I just created, and that's going to be the equivalent 10 ohm resistor. Now I can see that these two are in parallel, so I can redraw the circuit, and the equivalent there, that equivalent is going to be 5 ohms. So I'm going to redraw the circuit. So I still have 2 amps. It's still V plus to minus. So the way that this circuit is laid out, we're really only able to reduce one resistor per redraw of the circuit. So this is actually a kind of a circuit known as an R2R ladder. Not that that really matters for us right now, but it is interesting how many steps it's going to require to reduce the circuit all the way down to a single resistor. At each step, we're alternating a resistor combination in parallel and a resistor combination in series. So I'm combining two 5 ohm resistors in series to create a 10 ohm resistor. A lot of redrawing that goes on here. Whoops, I don't know why that got erased. So now I can see that these two resistors are in parallel. So I'm going to redraw one more time here. 10 ohm and 10 ohms in parallel is going to yield 5 ohms. And I have 5 ohms here. We're almost there. There's 2 amps. There's our unknown voltage. And now finally I can combine those two 5 ohm resistors in series. And now I am down to just a single resistor, and it is a resistance of 10 ohms. Voltage is plus to minus. I have 2 amps, and I can calculate by Ohm's law, V is equal to I times R. And I know that the voltage that appears across that current source is the same as the voltage that appears across the resistor, just as the current that flows out of the current source, 2 amps, is the same as the current that's flowing into the resistor. So V is equal to 2 amps multiplied by 10 ohms, and that works out to be 20 volts in this case. So a lot of steps, a lot of redrawing. You might be tempted not to redraw the circuit as often as I've redrawn it here. I'll say it this way. I redraw it very often. Maybe you're smart enough not to have to do it. That's always a possibility, but it always reduces the likelihood of an error if you redraw the circuit frequently so as to make only 1 or 2 changes each time you redraw it.